The question is to find out the cournot solution for the given oligopoly model. The question is, consider a three firms oligopoly market with a linear demand function given by P is equal to 25 minus Q, where P is the unit price and Q is the quantity supplied. The total quantity, which is Q, is equal to Q1 plus Q2 plus Q3, where Qi is the output from the ith firm with I equal to 1, 2, 3. The total cost of a firm I is given by, that is total cost TC subscript I is equal to AI plus 5QI, where AI's are positive real numbers. Assuming a Cournot solution exists, the value of Q, that is total quantity supplied in this market, is equal to, options are 9, 15, 12 or 21. Okay, so this is a Cournot model and we are being given the demand function, market demand function, that is P is equal to 25 minus Q. Okay, this is the market demand function. How do we solve the Cournot model? In this case, we know that in the Cournot model, firms compete in terms of quantities. Okay, equilibrium occurs where what we call the reaction curves of the firms intersect with each other. Okay, and how to find out the reaction firms? Let us first find out. Since we have three firms oligopoly model and we have symmetric cost here, okay, we have the symmetric cost here. Let us take the first firm, that is firm 1, and find out the reaction firm for firm 1. So this is the market demand function. Can I rewrite it like this? P is equal to 25 minus Q is equal to Q1 plus Q2 plus Q3. Here it is shown in a small caps, so I will write it in larger caps, that is in capital letters, because I get confused with Q's as 9. So can I write it like this? Q1 plus Q2 plus Q3. Okay, so total demand function will be 25 minus Q1 minus Q2 minus Q3. Okay, let us first find out the reaction function for firm 1. Reaction function of for firm 1. For firm 1, what is the equilibrium condition? That is the marginal revenue of firm 1 should be equal to the marginal cost of firm 1. To find out the marginal revenue of firm 1, first we need to find out the total revenue of firm 1, which will be equal to price times the quantity of firm 1, which will be equal to, so P is this very function, so we have 25 minus Q1 minus Q2 minus Q3. To this we multiply by Q1. So total revenue of firm 1 will be equal to 25 Q1 minus Q1 square minus Q1 Q2 minus Q1 Q3. This is the total revenue of firm 1. What is the marginal revenue of firm 1? So marginal revenue of firm 1 will be the change in the total revenue of firm 1 due to the change in the quantity of firm 1. That is the partial derivative of this function with respect to Q1. Derivative of Q1 is 1, so we are left with 25 minus derivative of Q1 square is twice Q1 minus derivative of Q1 is 1, so we are left with Q2, and here again Q1 is 1, so we are left with Q3. Okay, this is the marginal revenue function for firm 1. What about marginal cost? So total cost for firm 1 will be equal to, so TCI, in place of I write 1, which will be equal to A1 plus 5 times, so QI is Q1. So I am writing small q 1 is Q1 for the sake of simplicity. Okay, problem gasan huliakhnas. Having said that, what will be the marginal revenue, rather marginal cost of firm 1? That will be the change in the total cost of firm 1 due to the change in the output. Derivative of this function with respect to Q1. Derivative of a constant is 0, derivative of Q1 is 1, so we are left with 5. Now, equating marginal revenue with marginal cost. So marginal revenue is this very function, 25 minus twice Q1 minus Q2 minus Q3 is equal to 5. Okay, what will we do? Let us transpose this to this side and this side, so these becomes positive. So we have twice q1 plus q2 plus q3 is equal to, so 25 minus 5 is 20. This is the reaction function for firm 1. Rather, if I solve it for q1, then I will get the reaction function. Okay, reaction function simply shows how much quantity firm 1 will produce given others have produced their optimal quantities, that is firm 2 and firm 3. This is one of the equation for firm 1. Rather, this is the equation for firm 1 as reaction function. Since we have the symmetric cost, so output produced by each of the firm will be same. So symmetrically, what will be the reaction function for firm 2? That will be equal to, if you solve again, that is marginal revenue of firm 2 should be equal to marginal cost of firm 2. We will get q1 plus twice q2 plus q3 will be equal to 20. Similarly, if you solve for mr3 is equal to marginal cost of firm 3, it will come out to be q1 plus q2 plus twice q3 is equal to 20. Okay, so we have three equations with three variables and we need to solve this. Okay, we apply, and let me rub this out with heavy heart. So we need to write them into the matrix form. Okay, so in matrix form, that is Ax is equal to B, where A is the coefficient matrix. Okay, so A will be equal to the coefficients of Q1, Q2 and Q3. Coefficient of Q1 is 2 in the first equation. In the second equation it is 1, third it is also 1. Here we have 1, 2, 1, then we have 1, 1, 2. X is here what we are supposed to find out, the quantity of Q1, Q2 and Q3. And B is the vector of constant terms, that is 20, 20, 20, 20, 20, 20. Okay, this is in the matrix form. We need to find out the value of Q1. Okay, first thing is, okay, I am within my awqat. First I need to find out the determinant of the coefficient matrix. How do I find the determinant? So we write the first term, okay, then mentally delete the row and the column in which it appears and multiply it with the resulting determinant. So we have 2 2s are 4, minus 1 1s are 1. Then we write minus and write the second term and mentally delete the row and the column in which it appears and take determinant of the remaining element. So remaining elements are 1 1 1 and 2. So 1 2s are 2, minus 1 1s are 1. Then we have plus. Then we write the third term, that is 1, and delete the row and the column in which it appears and take the determinant of the remaining element. So we have 1 1s are move on. Then subtract 1 into minus 2, which is minus 2. Solving this, so determinant of A will be equal to, so we have 2 times 3, then we have minus 1 times 1, then we have plus 1 times minus 1. So we will get 2 3s are 6, minus 1, which is equal to 4. So determinant of A is equal to 4. Now to find out the optimal quantity of Q1, what we do, we apply the Cramer's rule. Okay, so in the Cramer's rule, what we do, to find out the optimal value of Q1, we replace the first column of the coefficient matrix with the vector of constant terms and form a new matrix, that's A1. So A1 will be equal to, so to find out the value of Q1, we replace the first column of the coefficient matrix with the vector of constant terms. So in place of 2 1 1, we write 20 20 20. So we have 20 20 20. Then we have 1 2 1 and 1 2 1 and 1 1 2. Then we take its determinant. Okay, so A1. Let's take its determinant. So we have 20. Delete the row and the column in which it appears and take the determinant of the remaining element. So 2's are 4 minus half. Then we have minus 1. Delete the row and the column in which this appears. So we have 20 into 20, which is 40, minus, sorry, 20 into 2 minus 20 into 1 is 20. Then we have plus 1. Delete this row and this column. So we have 20 minus 40, 20 minus 40. Okay, so A1 will be equal to 20 into 3 minus 40 into 2 is 40 minus 2 is minus 2, rather it is plus 20. Then we have again minus 20. So we have 60 minus 20 minus 20, which is 60, minus 40, which is equal to 20. So determinant of A1 is equal to 20. Now what will be the optimal value of Q1? Okay, using Cramer's rule, what we do? So let me repeat it again. To find out the optimal value of Q1, we form a new matrix A1 in such a way that we replace the first column of the coefficient matrix with the vector of constant terms. Sorry. And take the determinant of that very matrix. Then the value of Q1 will be equal to the determinant of this new matrix format divided by the determinant of the coefficient matrix, which is 20 upon 5, rather 4, which comes 4 1s are 4 5s are 20. So Q1 will be equal to 5. Okay. What about Q2? If we want to find out the value of Q2, what we will do? We will replace the second column of the coefficient matrix with the vector of constant term. Let me see, I have the space, and let me explain it here. I will not compute it. So then we need to find out the second matrix by replacing. To find out the value of Q2 star, we replace the second element, the second column of the coefficient matrix with the vector of constant term. So we have 2 1 1. We replace this column with 20 20 20 20 20. Then we have 1 1 2 and take its determinant. Okay, A2. It will come out to be, it should come out to be 20. Symmetrically, to find out the value of Q3, okay, you don't need to do it here. I will explain why. So to find out the value of Q3, what will we do? We form a new matrix, that is K3, or rather A3, by replacing the third column of the coefficient matrix with the vector of constant term. So we have 2 1 1 1 2 1. Then we have 20 20 20. Its determinant will also come out to be 20. Okay, so you don't need to calculate them. Then Q1 Q2 will be equal to A2 divided by A, which is 20, divided by 4, which is equal to 5, and Q3 will be equal to the determinant of A3 upon A, which is equal to 20 upon 4, which is equal to 5. We don't need to do this step, but I was just trying to explain it you about the Cramer's rule here. Okay, since Q1 is equal to 5 and we have the symmetric costs for the firms, that means Q1 will be equal to Q2 will be equal to Q3. Okay, that means total output will be equal to, total output in this market will be equal to, since Q is equal to Q1 plus Q2 plus Q3, and Q1 is equal to 5, that means Q2 and Q3 is also 5, so Q will be equal to 5 plus 5 plus 5, which is equal to 15. Okay.